We are talking about quadratic inequalities, and we want to be able to graph them. And we want to graph quadratic inequalities in two variables and graph systems of quadratic inequalities. So when we're graphing, there's two steps that we want to pay attention to. Step number one, graph the quadratic. And remember, if there's no equal to sign, so down here we have less than or greater than, we use a dashed line to represent the quadratic. If the equal sign is there, then we'll use a solid line. And then after we have it graphed, we need to check a point. If it's true, shade the region that contains the point. If it's false, shade the other region. And we'll get an example of that. So example 1 says graph y is greater than x squared plus 2x minus 6, and this is in standard form. So the first thing we have to do when we're in standard form is we have to find our line of symmetry or our axis symmetry. So use x equals negative b over 2a. So from our equation, we know a is equal to 1, we know b is equal to 2, and we know c is equal to negative 6. So right away, we know that our graph is going to go through at negative 6. So if I use this to count by ones, I'm going to be off the graph, so I'm going to at least have to count by twos. Next thing, we can substitute the values in. So the things that always stay, the negative always stays, the divide side always stays, and the 2 always stays. So we're going to substitute in 1 and 2. So in this case, we get negative 2 over 2, which is equal to negative 1. So we have axis symmetry at negative 1. And we already said that we wanted to count by 2's, so that's what I'm going to do. So 2, negative 4, 6, negative 8, 2, 4, 6, 8. And then I can sketch my line at x equals negative 1. So x equals negative 1 is going to be halfway between the y-axis and 2. So this is x equals negative 1. The next thing, we can use x equals negative 1, and we can substitute it into the equation to find out what our vertex is. So this helped us calculate the axis of symmetry, and now we're going to calculate the vertex. So we use our equation, and we got y, in this case we can say is, well, we can say greater than squared plus 2 minus 6, and we're going to substitute in the negative 1 for x. Negative 1 squared is negative 1 times negative 1, so that becomes positive 1 minus 2 minus 6. So y is greater than negative 7. So our vertex, we get the ordered pair negative 1, negative 7. So we can go ahead and plot that point. So -1 is right on the axis of symmetry, and -7 is between -6 and -8. So put the point right there. And then we also know that we have our y-intercept at -6. So I'll plot that point right there. Now, one other thing that we know is we know that the a value is equal to 1. So the a value is equal to 1. So this is going to be just like our parent function. So from the vertex, we go over 1, up 1. We already have that point there. So to the right 1, and then we go up 1 because 1 squared is 1. If we go to the right 2, we go up 4 because 2 squared is 4. So over 2, 1, 2, up 4. 1, 2, 3, 4. And we can check one more. If we go over 3, 3 squared is 9. We're going to go up 9. So 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. Then we can use our axis of symmetry to get the left-hand side. So how far is this away from the axis of symmetry? 1, 2, 3, 1, 2, 3. 1, 2, 1, 2, right in the middle there. 1, 1, and then we know that we're using a greater than sign, so we're going to use dashed. We're going to use dashed lines to represent our parabola. So we have a rough sketch of what our parabola looks like. Now we have to decide where we should shade. There's two regions. There's inside the parabola, and then there's outside the parabola. So we need to check a point. In this case, I'm going to pick the point 0, 0. And I'm going to check that. So 0, 0, and we're substituting that into our equation or inequality here. So is 0 greater than 0? 2 times 0 is 0. Is 0 greater than -6? And this is true. So we want to shade that region. So we want to shade inside because 0, 0 is inside. So shade inside the parabola. So our axis of symmetry was x equals -1. Our vertex was -1, -7. And some good points that we had were -1, -7 was the vertex. And then we had 0, -6 was the y-intercept. And then we had 1, -3. And we had -2, -6. And then we had -3, -3.